Good evening, my YouTube viewers. It's Crystal here. Basically, what I wanted to do is I wanted to give you another code review. And what we're going to be doing is we're going to be working on a multivariate, multivariate time series analysis. And so that's what this video is going to be about. We're going to be concerned about VARMA. And I'm going to take that because I did get it to work. I had put a note on saying it doesn't work on the models, but I did get it to work. So VARMA is used when there are two or more time series that are independent of each other. In VARMA, we assume there are two time series that have a correlation. And so the problem statement is this is a time series data set based on an actual department in a nonprofit organization in the UK. It has 3 columns, being the date, amount of waste collected, and cost of collection. So first thing we're going to do is we're going to create the program, and the program was created in Google Colab, which is a free online Jupyter notebook. Google Colab's really good, except for the fact that it doesn't have a very good undo function. So you have to be careful not to delete or overwrite any code, valuable code. One thing that you can do is if you delete a column or delete a row or delete a cell, you can go in here and undo delete cell if you like. And then another thing that you can do, if you accidentally overwrite some code or delete some code, you can go into Save Changes and you can go into Revision History, and there's a possibility that you can go back and retrieve the code. So that's one thing that you can do. But if you can't do the undo delete cell and you can't go into the revision history to get the code, then you're pretty much scuppered. But those are things you can do to try to retrieve code. So we'll import the libraries. After we created our program, we're going to import Pandas as PD, which is a data processing library. It creates and maintains data frames. We're going to import NumPy, which is a numeric library, and it performs numerical calculations and creates NumPy arrays. We're going to import Math, which is an inbuilt library in Python that does mathematical calculations such as square root. We're going to import Matplotlib, which is a graphics library, and it plots all of the data points onto a graph. We're going to import Seaborn, which is a higher level graphics library, and it also carries out statistical calculations when it's plotting the data onto a graph. We're going to import sklearn metrics, which has a mean squared error function in it, and sklearn is a machine learning library. We're going to import statsmodels, which is a statistical library. We're going to import itertools, which enables you to iterate through rows of a data frame. And we're going to import the warnings and get a note to ignore warnings. I should put that on another one of my programs, but I don't. So after we've imported the data, then what we're going to do is we're going to use Pandas to read the file. And when we use Pandas to read the file, you can see the file right now. We're going to read it into a data frame, and it has 3 columns, being month, year is the month and the year, total weight, and total invoice. And then now we're going to describe the data set. So you're going to describe the total weight and the total invoice. And so you can see that there's 75 rows of data. Gives you the mean, the standard deviation, the min, the 25 percentile, 50 percentile, 75 percentile, and the max. Then we check the info, DF info, so you can see that on that data set you have one object file, which is your date, and two floats, which is numeric. So you can see the DF again. So now what we have to do is, what I did was I made the time series in Excel, and the dates weren't compatible with Python. So what I have to do is I have to make the dates compatible with Python. So I inserted code to take the first 3 characters and make it a month, take the last 2 characters and make it a year. I'm going to drop the month year, and then we're going to add a 20 to we're going to create another column called month year equals DF month plus 20 plus DF year. Okay, so now what we're going to do is, after we have our month year, we're going to time step it. So DF month year equals PD to date time DF month year. And then so you can see the month year is now a date and it's not an object. So now what we're going to do is we're going to take the date and we're going to make it the index, and then we're going to drop month, year, and month year because those are not necessary. So now what we're going to do is we're going to graph the 2 columns. The amber is the total invoice and the blue is the total weight. So the invoice is actually dependent upon the weight. Now we've got seasonal decomposition from stats models, and so what that does is that decomposes the 2 time series. So you can see that this is the observed time series. You can see the trend. Both of the time series have an upward trend. You have a seasonal. It takes out the seasonal part of it, so you can see the seasonal part. And then the residual, that's like a noise. So now what we do is we do the Dickey-Fuller test to see if it is stationary. And what we do is we put it through a for loop, and we check every column in the for loop. And if the column in the for loop is stationary, then it lets it go. But if it isn't stationary, then what it does is it uses differencing to make it stationary. And so you can see the printouts here that the first row was stationary, and then the second row was stationary as well. And now what we do is we do a Granger causality test, and so that's another test, and then you test it on the 2 columns of data, and then you want to see what the causality is between total weight and total invoice, and then you turn around and you want to see what the causality is between total invoice and total weight. And so this Granger causality test tells you what they've got in common. So now what we're going to do is we're going to create the data frame that's going to be used. So data equals DF, total weight, total invoice, and it's 75 rows by 2 columns. And now what we're going to do is we're going to split our data set up into training and testing sets. So the train length is 90% of the data frame, and train equals data 0 to train length, test equals data, train length to the end, and then you check the shape. So on train you have 67 rows by 2 columns, and on test you have 8 rows by 2 columns. Now we check VAR, that's vector auto regression. So we define our model, which is VAR. So model equals VAR train, frequency equals MS, and then we sort it, and then we sort it with the number 3. So it means it gives you 3 sorts. And then you print the sort summary, and you come over here and you find the star. And the number where you have the star is the number that you should be using. So we do it again. Model equals var train, frequency equals ms, results equals model fit to results summary. So you can see the summary. But another thing that we can do is something that they like to look at is the AIC. Let's see. So we'll run it again and hope for the best. Okay, it's just taking a little while to run it. It's mounting the Google Drive now. So it says mounting Google Drive. This may take a long time to complete if you have a large number of files. So it started working. So the AIC is 33.55. Now we check our lag. So lag equals KAR, which is another parameter. Predictions equals result.forecast, train.values, and it's to the negative lag to the end. And steps equals length of test, and this is your predictions. And so you have 2 columns of predictions. You check your coefficient equals PD to data frame results.param, total weight results.p-values, total invoice. So that gives you some more information. That's your coefficient. We check our coefficient again. So we have a coefficient and a p-value. And then we query the coefficient whether it's less than 0.05, because it has to be less than 0.05 to be stationary. And then it checks to see if it's less than these values. And then coefficient valid equals NP where coef p-val less than 0.0510. So then you get the another data frame made out of that. Another coefficient dot array equals coef 1 to the end values, and the shape is 4 rows by 1 column. And here's your coef dot array, your four pieces of information. Now you do train, negative lag to the end. So you've got your total weight and your total invoice. You've got your in array equals train, and then it's negative lag to the end, and then it's the data frame to -1, and then you stack it, and then you put it in a frame and you transpose it, and so now you have 1 row by 4 columns. So here's your array where you have your 1 row by 4 columns. And now we find our dot product. This is to do with linear algebra. NP dot equals N array, coef array, plus coef 1 values. So now we do our predictions equals PD data frame, index equals index test.index columns equals predicted total weight, predicted total invoice. So now we have the predicted total weight and the predicted total invoice. So now what we do is we create a data frame where you compare the total weight, the actual total weight, to the predicted total weight. And you can see what the values are there. And now we create another data frame where you can see the predicted total invoice to the actual total invoice. And you can see the values there. And we plotted a graph so you can see the total weight, total weight is in blue, total invoice is in amber, predicted total weight is in green, and predicted total invoice is in red. So now what we're going to do is we're going to check the RMSE on the two columns. So the RMSE for total weight is 2465 and the RMSE for total invoice is 44314. So that was it for your VAR. And now we're going to use VARMA. And here's the code for VARMA that you can use this code, and it tells you which PDQ numbers to use in your prediction. So you can use that code. All you have to do is take the hash marks away, because the hash marks make it a remark. But I'm not going to unhash it because it takes a really long time for it to go through. And because it takes such a long time for it to go through, I'm not going to hash it. But you see you've got the code here, so you can write the code down. And what you do is just unhash all of it and run it. But it will take a long time for it to run. And so now what we're going to do is we're going to put it on, use the VARMA stats models method. Model equals VARMA train, total weight, total invoice, order equals 0, 1, 0, fit, DISP equals false. So you can see these are your predictions, your total weight, and your total invoice. So we want to see what the RMSE is at, and that's your error. So we run it on a little for loop, and you can see the RMSE for the total weight is 23,830, and the RMSE for the total invoice is 23,475. And we create a data frame, and we compare the actual total weight to the predicted total weight, so you can see the values there. And then now we create another data frame where you can see the actual total invoice to the predicted total invoice, and you can see the values there. So this is a diagram of the total weight against the total invoice. And so you can see that the total weight is blue, total weight predicted is green, the total invoice is amber, and the predicted total invoice is red. And so what we can do that doesn't really do much, does it? I'm just trying to see what's the best thing to do. That's what I'm doing. That's what I was being quiet, but I thought, well, I better say something because you might not really know what I'm doing. And then what we're going to do is I'm just going to see if it's going to work. Let's try it again. So we've got our result. So we've got our result, so we know what our result is. So it says total weight and total invoice. So let's just see what happens. Well, we've got to carry on with this code review. So we're just going to run it again. And so now we look on FB Profit. And you notice, so we finished it. I wanted to change it a bit, but I couldn't change it. Not without going into an error. And we have to carry on with the code review. I'm really sorry about that. So, let's try this. Let's try this. So now we've got our predicted, but it says not a number. So for some reason, it's just not working, and I can't. For some reason, it's not accepting predicted total weight and predicted total invoice. See, just say rename columns. Let's do that. How's that? Let's try it. So, we got it to work. So we got our RMSC, we got our actual total invoice, predicted total invoice, and now we have our total weight, total invoice, predicted total weight, and it should be predicted total invoice, and it's not. Total, actual total invoice, invoice, predicted total invoice, round. Actual total weight, predicted total weight. So that should say predicted total invoice, but it's not saying predicted total invoice. Let's try it again. It should say predicted total invoice. I just wonder if it'll do it like that. Predicted total weight. Try that. See if that does the trick. There we go. Predicted total invoice. So there you go. Now you have your total weight, total invoice, predicted total weight, predicted total invoice. Now what we're going to do is we're going to talk about FB Profit. That is a Facebook model. And so what we've done is we're plotting the train in our test file onto a map. And you can see that. You've got your X train and your X test. So now we split up with train, we reset the index for train, and we reset the index for test. And then what we have to do is we have to rename the columns. Month, year is DS, total weight is Y, total invoices add 1 in place is true. And then we do the same thing for test. So you have 67 rows by 3 columns for train and 8 rows by 3 columns for test. So now we set up the model to train and fit it. So model equals profit, model equals add regressor, add 1, model fit, train. So now what we do is we make predictions, and the column equals Y, so you come over here and we're looking for Y hat. And so at the very end you have Y hat. And so this is your test forecast for Y hat, and it's negative values. which it shouldn't be, because weight can't be negative and money can't be negative either, or not in this instance anyway. So we plot the forecast, and then we plot the components of the model, so you can look at your trend and you can look at your season, your yearly. And you can look at your extra, regress, or additive. And now what we plot the forecast of the actuals. And now what we do is we check our RMSE, or error. So we've got a pretty big error. So we've got, if the white hat is less than 0, it becomes 0. So everything is 0 except for the last one, which is 8509. And then so we plot it onto a data frame. So you can see that FB profit didn't perform very well for this data set, but this is just an example of how you can use FB profit in a multivariable data set. And even though it didn't perform very well on this particular data set, you can use this code on another data set and it might perform better. So that's it for this video. We had a few mistakes that we had to correct, but at least you can see how to correct those mistakes now. So I'm going to go ahead and close this video because I've spoken longer than I wanted to. But I would like to thank my subscribers for supporting my channel. And if you like this video, please like, subscribe, and share. And thank you so much for watching this video. And I will be making more videos for you in the future.